Good morning, everyone. In this presentation, we will be going over PropDefs and PropObjects. I'm going to be approaching these topics with an emphasis on best practices you can do when writing and working with them, and how to take into account performance, a few tips there, and how to keep them maintainable and stable for long-term extension development. My name is Kathryn Jones. I am a developer trainer here at Configura, and I've been at Configura for 8 or 9 years, and my role specifically includes developer training and documentation. All right. So in this presentation, I'm going to do a core concepts refresh. I'm going to go over just all of the underlying base ideas of PropDefs and PropObjects, just to make sure we're all on the same page. I'm not going to go too into details because all of the presentations for experience are approached with the idea that everyone attending or watching this has a fundamental understanding of the ideas behind them that they have learned in developer training. But I do want to make sure we're all on the same page, and it's always good to get a refresher. And I will have some graphics on like how I visualize the control flow and how those concepts work together. We're going to go over anonymous prop data, which is a tricky concept and sometimes gets confused with PropDefs and PropObjects. They sometimes overlap, but they're actually different systems. I have performance tips when working with PropDefs and PropObjects, a bunch of generic best practices, and then we'll do a quick review. Since this is the recording, for experience, we will not actually have the Q&A recorded since this is recorded beforehand. So if you do have questions, I can't actually do them here in the recording, but feel free to message me. I have my contact info at the end of the presentation, and you can also email dev support. I regularly am in contact with them, and I'm also in charge of documentation. So if there's info here that you would like included in documentation or that you think doesn't align with documentation or whatever, that is good information for me to know. And I'll have my contact info at the end of the slides. So to start off, we'll do a quick refresh on the base ideas behind PropDefs and PropObjects. So PropObject is the base class for most objects in CM. It is a base class that allows for dynamic data pushing and pulling. You don't need to know the data type of the receiver of the object who's receiving that data or the type of the data or the data type of the information that is actually being pushed. And this allows us for some really cool systems and interactions. So some example prop objects, animations, snappers, data, components. Most things will extend prop object. A couple don't, like window or control, but those have an additional prop object on them, and then it's kind of convoluted in order to be able to still do prop object behaviors on it. But for the most part, most things you're going to interact with are going to be prop objects. PropDefs, these are objects that you put on a prop object that define that object's behavior for any pushes and pulls that match a certain key. Core properties has the word properties in it, but it is not props or PropDefs or prop objects. This is the system of user interactive elements in the green properties box. So that is a different system. Anonymous prop data. Prop data is a generic string to object map that is a field on prop object. Anonymous prop data is put here, but regular PropDefs can also put information here. When we say anonymous, that just means there's no PropDef associated with pushing and pulling to that map right there. So these are all different systems. They all have prop in the name, but they do interact. All right, more info on PropDefs. So each PropDef is linked to a key. You'll often hear people refer to this key as a prop key. To customize a PropDef, use subclass PropDef, or you define it via prop syntax. And behind the scenes, prop syntax will create a hidden subclass of PropDef with a bunch of overrides containing all of your behaviors you've customized. PropDefs have many uses, but most importantly, they actually, most cases on most objects, anonymous prop data will not be allowed. By default, it is false. And in that case, putting a PropDef on something for a key will actually enable put and get in the first place. So that'll actually allow you to put and get to a key at all by just providing a PropDef for that key. You can also customize put and get behaviors, or you can customize other behaviors like domain or whatever. I have a list later on. But you can also trigger reaction code. Say like when I put a value, instead of putting to this field, I actually want you to just open a window and run this function. Or after you do put to that field, I want to now update all my connectors and then trigger an undo step that actually shows something to the user and whatever. There's a lot of stuff you can do. It's basically an open-ended way for you to customize what you want to happen when you push or pull that data. You can also allow the generation of core properties. Those are the properties in the green properties box. Since the core properties system is actually agnostic of your class types, as long as you extend PropObj, it just looks at the PropDefs you have and searches for PropDefs that respond to it with information that can build properties. So there are certain types of PropDefs, or there are PropDefs that when you set them up properly, will actually give certain information to the core property system, and then the core property system will handle the generation of those green properties. So the effects of having this system in place, PropDefs and PropObjs that lets systems without shared base classes interact. We don't have interfaces, and things still need to interact, and sometimes you can't cast because you don't have exposure, like you do not have access to the package that those classes are in. You don't know they exist. You don't want to have to cast for every single class that could possibly exist in the code base. So this is like everything shares a base class called PropObj, and it has put and get. And so this lets systems interact without needing to know about each other. So this means you don't have to create dependencies. The systems don't actually have to have full knowledge of each other. You don't have to add those other packages to your package.cm and have those know about each other, and they can still interact. Something that is very, very important when thinking about PropDefs is that they should not make your class function. They just interface with already fully functional classes. Like you have a complete class, you just need a way for something to interact with you when it doesn't have access to your type. So we'll talk a bit more about this, but that is one of the most important ideas that you should keep in mind while listening to this presentation. So I'm going to show you how I visualize PropDefs and PropObjs when I'm working with them. This is how I think about them and how I keep everything straight in my head. Hopefully it's helpful for you all also, but if it's not, I apologize. So object is the base level object class in CM. PropObj extends that. It has a field for all of your PropDefs called defs. It has a field called PropData, which is the generic string to object map. And then it has the put and get functions. The PropDef class also has put and get functions. By default, it will point and put and get from the prop data of the owner object. So that would be the prop object. There are also other methods you can override on it to customize, like domain, default, setting, label. A lot of them have to do with the core properties system. But there are other ones you can also override to customize. You don't have to only override put or get. Field PropDef is a subclass of PropDef. This basically just overrides put and get and references a field instead of the prop data. Instead of the prop data on your prop object. There's going to be a few more parent classes in between probably, but essentially your subclasses will end up being leaf classes of prop object. In my example here, I have a desk class. I've given it a width field. As we start, I'm going to say we're not going to allow anonymous data. That function is defined on prop data, and I'm going to say return false. We're not going to allow that at first. And I'm going to put two PropDefs on here. The first one will be a PropDef that is not a field PropDef, just a regular PropDef. And I'm going to override its put. I'm going to say do your normal behavior, and then once you put something to there, I want you to update connectors. For my width PropDef, I want it to be a field, and I'm not going to customize anything at all with it. I'm just going to say give me a field PropDef with the key width. So now we'll go over some examples just so I can show the control flow through all of these in different situations. So example 1, we're going to do a put or a get. There's for something that does not have an associated PropDef on an object that does not allow anonymous data. So I'm going to have my desk object, and I'm going to do a put call to it using the key banana phone and the value just 12. So it is going to go to the put on the prop object. It's going to check, does a PropDef exist? And as you can see on my desk, there is no prop object or PropDef with the key banana phone. So that is not possible. Then it's going to see, hey, do you allow anonymous data? My desk does not allow anonymous data. So therefore, the value is just going to be trashed. It is silently going to just be discarded. That value isn't going to go anywhere. Example 2, we're going to put and get a value with no PropDef, but yes, we're going to allow anonymous data. I'm changing allow anonymous data to return true. So I'm going to do the same thing. I'm going to put to the key banana phone, and I'm going to put the value 12. So it's going to go to the prop object's put. It's going to check if a PropDef exists. We know that it doesn't have one. It's going to check if anonymous data is allowed. And it actually is. Allow anonymous data returns true. So it's going to put that value into prop data. It's going to do the key banana phone value 12, and it's just going to be an entry in that map there. For our third example, we're going to put and get, and we're going to put and get to a field PropDef, not allowing anonymous data. So I have a desk. I'm going to put width to the key width, and I'm going to put 12 inches. So it's going to go to the put call. It's going to check if a PropDef exists, and we do have one. It's going to forward onto the behavior defined by this field PropDef, which is defined over here. And it's going to look at that override of the PropDef's put, and it's going to put to the field instead. So it's going to put that value here. Get will do the same and pull from that field right there. All right, last example. So we're going to put and get with a regular PropDef, not a field PropDef. So I'm going to put to my desk for the key depth and the value 12. We'll go to the prop object's put. It does find a PropDef that matches that key. So it goes to there, and I have overridden the put for this. And so instead of going to the put in the base PropDef class, it's going to my subclass of this. So first off, in my override, I call super, so it's going to go over there. And that value is going to get put into my prop data field. and then it will run any other customization code after that I've run. And in this case, that is just updating the connectors. So you can see this is like a good way to visually imagine the flow of how everything works. So I hope that has been helpful. Now we will talk a bit about anonymous prop data. We're going to go a bit into this field right here. So prop data is simply a plain key value map. You can really just put anything there. This field's on PropObj, and by default, allow anonymous data is false. In my example image here, it's overridden to return true, but by default, it does return false. If you override it to return true, then any put or get call that you make on that prop object will simply put and get info from this map right here. So looking at this field, your first instinct might be to store a ton of information here. Because if you store info here, then every other class can access it without needing to know my class type or a field name or anything like that. I know that was my first instinct when I first discovered this. You could do that, but don't. I know I originally had thought, oh, I can store all of my useful information here regarding my snapper class. And then I can have anyone grab it, and I don't need to cast, I don't need to have code dependencies between my packages, and it seemed a good idea. But best practice is almost always to prefer explicit PropDefs over just using anonymous prop data. So why not? Basically, prop data is just a lump of miscellaneous info. You're going to eventually lose control over it if you start using it a lot. And when it gets large enough, you're going to lose meaningful information about it. You'll get lots of questions and you don't know, like, hey, why is this entry here? What does this key mean? Is this necessary anymore? Why are these here? Do I need to do load code on any of this? What is it actually used by? I can't Alt-I on this. How am I supposed to, this developer from 8 years ago doesn't work at the company anymore, added this entry here. There's no way to actually keep meaningful context for any entries in this map. So, and because you can't Alt-I on anything in it, it's hard to see why it's there or what it's used for. Secondly, anyone can put anything in there. I could, in my extension, go and touch. Sorry, my headset turns off if it doesn't actually hear any sound every 15 minutes. All right, so anyone can put anything in there. If I were a particularly bad dev, I could do it, find every snapper in the drawing and put a bunch of random information to every single snapper there. That includes snappers that are not from my extension. That's snappers from other people's extensions, Configura ones, the floor snapper, whatever. And I can put a bunch of trash information on there. So even if, so you're basically opening an object up to just storing anything. And most importantly, performance. A field will always be faster than storing any information in this field, sometimes drastically. So if you want your field accessible to other systems who don't know your class name, just provide a PropDef to them. That PropDef can access your field. Direct field access is always going to be the fastest informational retrieval method. This is the base get call on PropObj. And as you can see, there is a lot of things happening, a lot of checks and code that actually has to run before it even gets to the fall through case that is using the anonymous prop data. And once it gets there, it has to access the info via a map, which by itself alone is slower than a field call. As developers, we should always be keeping performance in mind when developing. We are developing for our users, and we want to make their lives as easy as possible, that they don't have to worry about this is really slow and this is really annoying and this started chugging along and my snappers started like slide showing. Basically, we want to have as good a performance as possible, and it's good to keep a mindset of performance when developing. Therefore, best practice is to just use fields with direct field calls. And if you need your objects available to outside systems that don't know your type and can't know your type, then make it available to them via a direct PropDef instead. So if there are so many problems with anonymous prop data, what are actual use cases for it? When would you actually use it? I can't give you a hard and fast rule for this is when it's a good idea to use anonymous prop data. This is why it's important for everyone to really understand how it works so that if you have the idea to use it, you can evaluate that idea to see if it's wise or not. Legitimate use cases are going to be few and far between. In all of my 8 or 9 years at Configura, I've actually only ever seen 2. The first one was temporarily storing info on an animation that I could not override or provide a custom animation for. Like my snapper was being animated and I needed to track its state over time, but only within the context of that animation. And I couldn't provide my own animation. So I just shoved some data onto the animation to its prop data and then grabbed it off when I needed it. And that animation was temporary. And then once it finished, that was gone. I didn't have to worry about it staying around afterwards. And a senior developer here at Configura also had a really cool system he came up with for doing auto supports and accessories on data symbols. He created a behavior class and he put that class in the prop data on data symbols. And they did have to have an extension to define that behavior, but they were able to get auto supports on actual data symbols, like pure catalog symbols, and that was pretty awesome. Okay, so another performance tip when interacting with PropDefs and PropObjects, something you should just keep in mind, is that the method propChanged. This runs whenever you do a put call and it puts a value and changes a PropDefs value, and there's an old and a new value and they are different. PropChanged will get called and you can override that and provide reaction code there. The problem with this is that everything in propChanged runs for every propChanged, not just it doesn't just get run for the prop you changed, for every time any prop changed. And there's a lot of PropDefs in all of the Configura base classes. There's going to be a lot of things there. So put is called a lot by everything all the time. So instead of making CET run 12 if-else statements or a switch or something of the sort, like if your key is this, then react this way. If your key is this, react this way. Else if, else if, else if. Instead of doing that, if all you're doing in propChanged is saying, if it's this key, do this. If it's this key, do that. Then put that reaction code in the put call for your PropDefs instead. I have an example of a long-ish propChanged, definitely not the longest I have ever seen. This is more of a average propChanged from all the extensions I have worked on. Instead of doing this, you can see 2 of the keys right here. If your key is width, invalidate, update connectors, and if it's depth, also validate height. So both of those could instead be moved to reaction code for the actual PropDefs themselves. By putting this reaction code in the actual put or get of the PropDefs, you are removing those cases from propChanged and reducing the amount of performance that will be taken up every time anything is changed via a PropDef, and you will be reducing the time spent in propChanged. This isn't like a universal never used propChanged. This is just a tip, so use it wisely. The fewer things that actually have to happen in propChanged, the better. So you should minimize the things that are going to exist in this method to occasions that make the most sense. For example, you have 15 PropDefs and they all need to trigger the same snapper reaction on put. Adding that to every single PropDef is a pain to write as a dev, but if you're really going for performance, you would do it in the put call. PropDefs are designed to be as performant as they are at any scale. So scaling with the override of the PropObj's put. Actually, so if I were to try to do this by overriding the PropObj's put, not the PropDefs put, but the PropObj's, it wouldn't achieve the same thing either. The same problem would happen. You would get a whole bunch of if else, and the scaling would be disgusting. So PropDefs are actually meant so that 5 PropDefs or 1,000,000, it's just going to be one hash lookup. Technically, the performance will go up, but it's orders of magnitude less than a series of if checks would. So scaling up a propChanged will start getting really, really slow when you have many checks. So be smart about it, and whenever possible, try to put things in your actual PropDefs instead, because those are written to be as performant as possible at any scale. We're going to talk a little bit about caching of PropDefs. So by default, PropDefs are not cached. When you do cache them, they become singletons. This is pretty good for saving memory, especially when you have lots of objects. A good case or a good example of that is in material handling extensions, where users will have drawings that are hundreds of thousands of snappers. If each one has 25 PropDefs, that is a lot of memory that's being taken up. So if you're trying to minimize object creation, cache your PropDefs. If you're going to cache them, keep in mind that they are often wiped and recreated, which is one of the reasons that caching them is convenient. There are 2 ways to cache them. If you're using the PropDef syntax, you would just add cached equals true. There are examples of that in Fika. If you are adding your PropDefs by overriding your PropObj's append PropDefs method, you'll have to do an explicit function call to make those cached. So if you are trying to minimize object creation, cache your PropDefs. So another tip, your PropDefs should only define behaviors. You should never let them have state. They should never store information. They only saying, this is how you react. This is how you react. This is what you will do. They are only defining behavior. There are counterexamples in Configura code. They're not good. Do not use these as a valid example. ds-propdef alone has caused me many, many hours of bug tracking. And it also breaks caching. So do not store state on your PropDefs. The PropDef system is designed not to care about how often PropDefs are cleared out or when they are, so don't rely on them being kept around and persistent. If you try to store information on them, you will never know when it's going to clear it out and where that information is going to go, when you'll have to put the information back on, etc. All right. Something to keep in mind in terms of a performance mindset is that the fastest way you can access information is through field access, just a direct field access. Second most performant will be direct method calls, and then PropDefs. XAPI sounds nice and sounds convenient, but it is much slower than everything else. So following this logic, don't create PropDefs without an intended use case. So don't just turn all of your fields and public methods into PropDefs and only access those instead. Does it actually need to be a PropDef? Could you just use regular field access or direct method calls instead? Anytime you typecast, you should. PropObj and PropDefs systems are for when you can't do that. So the message to take away from this is that anytime you typecast, you should, and create your PropDefs with an intended use case. Going back to object creation. Many times developers will want to minimize the amount of objects created. It's a major problem when you're doing object-oriented programming. Everything creates an object, everything is an object, and all that has to be kept track of in memory. So in order to minimize object creation, one of the things you could do that I know a lot of material handling extensions do is completely avoid using the prop data field on PropObj, either anonymously or through like plain PropDefs. The prop data field is not copy reference. So if you have 200,000 snappers in your warehouse drawing and a material handling drawing, and all of your bays and all of your unit loads are the exact same snapper, and you just copied and pasted it to get it to fill it all out. If you do the prop data field is not copy reference. So if you put a single integer into that map is going to be initialized, and that is 200,000 more objects that now need to be kept track of. So if you are absolutely trying to find every single corner that you can cut in order to avoid object creation, just don't even use the prop data field. Instead, put things in fields, make PropDefs that point to those fields, and then make those fields copy reference. This is a pretty important one, and I know a lot of developers have found a lot of grief in trying to figure out how to set initial values when they are doing their prop syntax and they are defining their PropDefs. This is pretty important for when you're writing your PropDefs to be stable and easy to maintain long-term and knowing what behavior to expect. When you are setting an initial value, a default, you have a few options. I'm sure you've seen v equals. Here's an example here. So you can, once you define your PropDef in prop syntax, you give it the key and you can do v equals and give it your initial value. This is going to have really inconsistent behavior. It does not work with non-nullable types. These are going to be primitives like integers or doubles. This compiles, but doesn't work if you actually put it after the colon. And it also depends on what separators you use. So ultimately, it is not consistent or useful from what we have found. It still compiles. You can still try. It'll work sometimes, but that's not good. And if you're a developer and you don't know these facts, it's going to be a huge pain figuring out why it didn't work. Secondly, you could override the default on PropObj or on your PropDef. This also has some problems. It also does not get called for field PropDefs with non-nullable types like int or double or angle, which is inconsistent behavior. It'll still compile. You're going to be like, why didn't it work? Well, it only works sometimes. That's really annoying. Or you can initialize your values in your PropObjects constructor and then not have the PropDef initialize them at all. So this is the actual recommended best practice, because if you think about it, what does having a value initialized, giving it a default, what does that mean as a concept? You are giving it the initial value. That should belong to the constructor of the object. The PropDef should not have the job of initializing something. Its job is to expose info or behavior without doing a test. It's not the PropDef's call to make and actually do that initialization. So if you so that is something I don't know about all of Configura, but that is definitely something I recommend, is just doing your initializations in your constructor and then not even having your PropDefs initialize anything. Because logically, it should be the object initializing its own values anyway. I also have a few miscellaneous tips from all of my experience and talking to other developers here. Never put in beginner end of undo steps in your propChanged. Just do it. Just don't do it. You're gonna get a lot of problems, and you're gonna go to dev support, and dev support is gonna tell you, don't do that. Don't create PropDefs and stick them on other objects. Since we don't know If there's no way to predict, yes, my PropDefs will get cleared out here and not here, and yes here and not here, you don't know every single system that is happening, working at the same time. PropDefs are designed to be cleared out and recreated whenever. So if you make a PropDef and stick it on something else and you expect it to be around, it'll get cleared out and you won't know when you need to put it back on. So just avoid that entirely. When you are creating your PropDefs, design them for reusability across product lines and extensions. Try to put them on shared base classes, and this will allow you to do common behavior sharing. Kind of similar to like the group code concept in data with schemes. You want a scheme field to apply to everything, as many things as possible. So you give it all of these different features the same group code. They need different feature codes for one reason or another, but giving them the same group code means a scheme can apply to all of them. A similar kind of idea can apply to your PropDefs. You can design for reusability. This one is a more minor one, and it's more, once again, it's applicable mainly to people who are extremely performance minded. That's going to people who are writing extensions that users are going to be using when they make giant drawings, particularly material handling, because you're getting hundreds of thousands of snappers in one drawing. When you are defining the input setting for a PropDef, the input setting being the instructions that the core properties system will use to generate the green properties box. You can do it one of two ways. You can override setting or you can override input setting. It's better to use setting rather than input setting because this one adds the setting to the PropDef itself and it stays there. If your PropDefs are cached, then you'll actually only have to make it once. If you override input setting instead, it's going to create a throwaway object and it's going to add that to the propdef.info object. That's a throwaway when needed and it gets wiped and created and replaced often. So if you want to minimize object creation in every single place you can, use setting instead of input setting. This is just one last shout out to the inspector. I love using the inspector to look at all my PropDefs because it takes them all and it puts them in this really nice table. It shows me everything in a nice table format, its keys, its types, if it's linked to a field, what its current value is, does it have a domain associated, does it have a setting, is it piped? And it's a really nice way to just see everything all at once. You can also see if you look down here, if you remember an example from a few slides ago, I put a random number to the key banana phone. And I allowed anonymous data and I did not have a PropDef with the key banana phone. That information just got stuck into the prop data field. Sorry, headset turned off again. This is the problem with not having other people responding to me. So yeah, and you can see the prop data field here. You can see the actual PropDefs defined in the defs field. The inspector is really useful for examining what PropDefs and prop info actually exist on your prop object. So things to take away from all of this. PropDefs are very powerful and very useful, but you should write them with purpose and with thought behind them. Cache when possible, trying to increase performance of your extension whenever possible. It's really nice for users. PropDefs are for behaviors only. Never state. Don't store information on them. Use propChanged intelligently. Your ideal goal should be to never have to override propChanged. It'll happen sometimes, but whenever you can, put all your reaction code in the actual PropDef instead. Only use the anonymous prop data if your use case can't be solved with explicit PropDefs, fields, direct method calls, or anything else. Use field access and direct method calls when possible. Don't rely on v equals or default for initialization. Let the snapper handle it itself on construction because it's its job anyway. And avoid creating unnecessary objects, especially if you are writing an extension for users that will have giant drawings. And that is all. Feel free to contact me. This is my email. I am on the developer experience team here. I am a developer trainer, and I also work on all our documentation. And probably most importantly, here's my cat tax of my little cat named Inoki. Thank you, everyone.